Now, as much as we love epic space battles with blasters cutting through the black void and causing cheerful booms, that's not exactly what happens when something explodes in the big black. Space is basically vacuum, meaning it has no oxygen, and oxygen is an essential part of any process of burning we have here on Earth. You might argue that stars can burn and explode into supernova, but that's not exactly true either. Stars don't rely on oxygen, so they're not burning. There are constant thermonuclear reactions going on inside them. So a spaceship can only explode like that if it has a nuclear power plant installed in it. If it doesn't, then the only special effect you get is a brief flash that disappears in the blink of an eye. Liquid oxygen, which is often on board spaceships, is very quick to burn out in the vacuum of outer space. As for the boom, oxygen plays a crucial role here too. Sound only travels thanks to molecules of air bumping into each other. Since there's no air in space, the whole scene would be pretty much absolutely silent. And that's not a bad thing either. Just imagine how deafening would the sun be if the sound could travel in space. Despite what many sci-fi directors want us to believe, there's no dark side to the moon. Our satellite is tidally locked with Earth, meaning it's always turned to us with one side, while the other always looks away. The sun is much farther from us than the moon, and we're both turning round and round, warming and lighting this side and that in turn. It means that once in every short while, the moon is lit by the sun from either side. It's just that we can't see it from where we are. While things appear weightless in outer space, there's actual gravity all over the place. It becomes weaker the further you get from a heavy object, like our planet, but it's still there. In fact, there's not a single place in the universe that isn't affected by gravity of this or that cosmic object. Everything that has mass has gravity as well. Yes, even you and me. But space objects are so massive that they tug smaller things towards them. That's why the planets of the solar system orbit around the Sun, and our whole Milky Way galaxy orbits around its own center. Scientists believe there's a supermassive black hole there, about 4 million times heavier than the Sun, which keeps all the stars and systems from flying apart. Our movie hero leaves the orbit of Mars on their trusty spaceship and heads on towards Jupiter. Their face is grim and determined, even though they know what threat awaits them ahead – the asteroid belt. They pitch and yaw, dodging the asteroid flying at enormous speeds toward the spacecraft, but one of them still hits it. No, just a scratch, thankfully. Finally, our hero leaves the danger zone and wipes the sweat from the brow with a shaking hand. Sounds familiar, but couldn't be further from the truth. Asteroids in the belt between Mars and Jupiter are so few and far between that if you ever travel through it, you might not even encounter one the whole way. There are about 1.5 million sizable space rocks flying there, give or take 500,000. But let's not forget, space is a vast place. The distance between two asteroids of any significant size would be millions of miles. So a space chase with two ships weaving between floating rocks would be quite boring in there. Space is often depicted as a black, cold, and desolate place, especially when a movie astronaut leaves the safety of their spaceship. Everything about this description is okay, except for the cold part. It's only true if you find yourself in some really far corner of our galaxy that has no nearby stars. But if you're, for example, in the Earth's orbit and directly facing the Sun, the temperature in the cosmic vacuum could reach a scorching 250 degrees. That's why spacesuits are white. This color reflects light better than any other. Still, the temperature at your back, which isn't exposed to the sun's rays, can be really freezing indeed. Heat doesn't spread equally through space, so if you're not turned towards a heat source, you get very, very cold. Speaking about the sun, it somehow always appears yellow in movies. The fact is, the color we see from Earth is an optical illusion created by our planet's atmosphere, just as the blue sky during the day. The light from the sun spreads in the atmosphere and gets distorted, making colorful spectacles at dawn and dusk. In the vacuum of space, there's nothing to reflect the light, so the sun appears as it really is, white. That ball of glowing gas is that hot. There's a bright flash in the sky, followed by a tail of smoke, and a red-hot space rock crashes into the ground, leaving a huge charred crater after impact. Well, although the smoky tail and the crater are partly true, meteorites don't really have a chance to become that hot while falling. Meteorite is an asteroid that somehow entered the Earth's atmosphere and survived the friction enough to fall on the surface. This happens pretty often, we just don't usually see those rocks because they're normally quite small and fall into uninhabited areas. But even if one falls within a city, the crater would appear because of the sheer speed of the meteorite, not its heat. They do get much hotter because of friction, yet not so much as to burn everything on the ground on impact. As much as we want to believe in instant communication between spaceships and planets, it's not possible, at least not yet. Modern communication systems rely on radio signals that have a pretty slow speed compared to the vast expanses of space. It would take years for such a signal to travel even 1 light year, let alone hundreds and thousands. If you want to send a message to a galaxy far, far away, be prepared to wait a couple of millennia, and then a couple more to receive a reply. On that note, space is not as crowded and full of events as is often shown on the silver screen. It's mostly a rather lonely place, where planets, stars, and other objects are separated by billions of miles of nothingness. Even if you have a spaceship that can travel at the speed of light, most of the time you'll only see black void full of stars and planets far away. The distances are enormous out there, even between the closest objects. For a better understanding, the Moon, which you can see so well on a clear night, is about 239,000 miles away. It's like traveling around the Earth almost 10 times in a row. Warp drives that can distort space-time and get you to a distant corner of an alien galaxy in the blink of an eye, that's a staple of any space opera. Spaceships capable of such a feat are always shown as instantly accelerating from zero to faster than light. According to the law of physics, people on board should, well, at least be pushed into their seats hard. More strictly speaking, no one would be able to survive such an acceleration because it's too many G's on a fragile human body. Until we find a way to reduce the effects of overload, we can't even start thinking of space warps. Water isn't the rarest and most precious resource in the universe. In fact, there's a humongous space cloud several million light-years away from us that consists entirely of water. Its reserves would be enough to fill all our oceans 140 trillion times over. And many planets, some even in our solar system, seem to have liquid water on them. The most precious resource in space is life, and that requires a lot more stuff to appear than just liquid water. Astronauts are often shown working out on the ISS and sci-fi space stations, and that much is true, they do need physical activity. But the reason isn't that they need strong bodies to work in space. The gravity out there is much weaker, and astronauts don't use their muscles as much as on Earth. So when they come back to the surface, gravity hits them as a sledgehammer, and their bodies feel squishy. To alleviate those effects, they train every day. Although they say we can see millions of stars on a clear starry night, that number is much more modest, about 3,000. All the rest are other objects that are also luminous and mistaken for stars, planets, distant galaxies, and even artificial satellites. They're simply being illuminated by real stars, just like the Moon, and become seen. But because they're that far away, we can't tell if they're stars or not. Still, you gotta admit, it's all still pretty cool.
You've been training for this for years. You know you're ready. You're standing on the door's threshold. You take a deep breath and bravely open it. You jump outside the International Space Station and into the vastness of space. Ah, this never gets old, you say on the transmitter device. You feel like a feather whenever moving through space. Except for the suit, of course. It's true what that guy told you one day. Astronaut suits limit your body's movement by 20%. For you, that means you've got a 20% higher chance of being clumsy in outer space, which is never good odds. There's not a lot of room for error during a spacewalk. You finally get to the docking port. You look around and see the part of the station that needs fixing. This is where other space shuttles dock when they come in from Earth or other planets. About a week ago, a shuttle coming from Jupiter miscalculated the landing and broke a piece of the port. You've attached the new shield to your suit's belt. Now all you've got to do is screw it on the station. You've spent hours training underwater to do this. You wore a heavy, hot, uncomfortable suit inside a pool in order to get the training you needed. Incoming! Sarah shouts on the transmitter. You don't even have time to ask what, as an absurdly fast storm of space debris catches you off guard. It shakes everything around you. You try to hold on tight to the strap that's keeping you safe, but oh no! A piece of debris just hit your helmet shield. Come in, Bob, are you okay? Sarah asks you through the radio. You got a bit shocked by the impact, but everything seems fine. The meteorites are finally gone, so you can focus on your task now. You pull the rope that's connecting the new docking shield closer to your body, but the other part of the rope has nothing on it. Zip. Nada. Oh my, you think to yourself. Come in, Sarah, we have a lost shield. I repeat, we have a lost shield. This is a pretty serious situation, and you are aware of it. Anything that falls into space can go into a collision route with the International Space Station or with other space vehicles. You try to remember your training, but your mind goes blank. This is worse than that one time you broke your girlfriend's favorite ceramic jar. Sarah, the other astronaut who's with you on the ship, is shouting words on the transmitter. Oh no, Bob. Tell me you didn't do this. This is a total catastrophe. I'm coming outside. You spot the shield under the ISS. It's the size of a medium-sized car door, and it's moving quite fast. Here's what can happen in this scenario. The shield could head back down to Earth and break into the atmosphere. It would probably catch fire and disintegrate on the way down, but anyways, it would make NASA and you look pretty bad. The other option is the car door-sized shield gains momentum, and it orbits all the way to hit the ISS, and you for that matter. Or some satellite that happens to be in a similar orbit. Here's the thing. If you ever thought that space was an infinite void, you got that part wrong. Since different countries started to build equipment strong enough to travel in space, space has been more crowded than ever. Not with people, but with satellites, asteroids, and space debris. You were surprised when you learned that Earth receives meteorite showers every single day, but they're so small that no one on the surface of the planet notices it. They usually turn to ashes before hitting the ground, but that's not all. What just happened to you on this mission has happened on several other missions before. Astronauts keep losing stuff in outer space. So much so that NASA had to create a division to track down and monitor the orbit of all debris that is just floating carelessly around. You couldn't believe it when someone told you that there are over 23,000 softball-sized pieces of debris roaming around in space, and if we're talking about smaller objects, then that number goes up to 500,000. As you were about to unstrap yourself and dangerously venture through outer space without any protection, you notice Sarah has beat you to it. You can't let her do this alone, so you decide to tag along. FYI, this is against every NASA handbook and training you ever received in your life. But you think, if this works in sci-fi movies, it must work for us. Even though we all know that's very far from the truth. Sarah's close to the debris shield, but her body weight makes her orbit in a completely different direction. Okay, you think to yourself, this is your turn to shine and be a hero. You try moving your arms like you would do underwater, but there's no friction in space. Duh. You can't butterfly swim your way to rescue the rogue equipment. You try to contact Sarah, but she doesn't come in. I guess you're on your own now. For some reason, you start to orbit in a similar route as the floating car door shield. It must be the amount of stuff you've got strapped onto yourself. Or maybe it was the breakfast burrito you had that morning. You feel like you're George Clooney in the movie Gravity. No, better yet, you feel like Obi-Wan Kenobi. Yes, you're feeling as strong and powerful as a Jedi right now. You keep your hands stretched before your body, hoping you'll gently collide with the space debris. And 3, 2, 1, and the landing was successful. Just joking, but yes, you managed to dock onto the debris. Hooray. Now what? You think? Guess you needed to have gone through that plan of yours a little bit more, huh? You still have no way of steering the debris. And now, you have no way to contact Mission Control and tell them the object, and yourself, are en route to somewhere. Don't get scared. You didn't come this far to get scared. What's the best thing you can do? First, take a mental picture of the Earth. It never disappoints from up here. Then, you try to play out the possible scenarios that could happen in the situationship you're in. Your normal body weight would not be enough to get you out of Earth's orbit. In the hypothetical scenario in which this did happen, you'd probably be vacuumed into Venus's orbit and spend a quite unpleasant period of your life around immense heat. Even though in Greek mythology, Venus represents love, there is nothing lovely about orbiting close to this planet, and you know this. If you got too close, your spacesuit would never be able to take on the heat. It's only made to sustain temperatures of around 250 degrees Fahrenheit tops, and Venus's atmosphere can heat up to 700 degrees Fahrenheit. But honestly, the worst-case scenario is much simpler than that. Your spacesuit could decide to drown your ears, nose, and mouth in water. Yup, this has happened on spacewalks before yours. You see, in order to keep your spacesuit chill and cool, the suit relies on a gallon's worth of water that makes up for a cooling system. This system, which is supposed to send recycled air into the back of your helmet, does leak sometimes. And since you're stranded in the middle of the big nowhere, you'd have only that nowhere to run. But wait, what's that popping up on the horizon? It's a modular space shuttle. You try shouting, but nobody can hear you outside your helmet. You wave with your hands. But it's coming straight at you. Finally, it took longer than I wished to find you, Sarah said. Apparently, she made it back to the space station just in time to catch you before you went definitely rogue. Guess I'll be losing some astronaut points for this little misadventure, huh? You say. And yes, you definitely will.
Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out, Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen. But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future.
Have you heard about a diamond star that could put all the riches on Earth to shame? Or how about twinkling stars with surfaces made of solid iron? So let's take a look at these weird stars and try to unravel their mysteries. There's a star in the Centaurus constellation that was nicknamed Lucy in the Sky with Diamonds. Yes, it was named after a Beatles song, because it basically is a Beatles song. You see, the star was discovered to have a massive diamond at its core. Now, you may be wondering how big this diamond really is. Well, it's estimated to be about 10 billion trillion carats. That's a 1 followed by 34 zeros. To put that into perspective, the Hope Diamond, which is one of the largest diamonds on Earth, is a measly 45.5 carats in comparison. Can you imagine the size of the ring you could make with this star diamond? And it's about the same mass as our sun. But don't get too excited about the prospect of owning this diamond just yet. Even if you were Jeff Bezos, you wouldn't be able to afford it. According to Ronald Winston, CEO of Harry Winston Inc., the diamond is so big that it would likely depress the value of the market. So you'd have to settle for a much smaller diamond engagement ring. One interesting thing about the Lucy in the Sky with Diamonds star is that it's incredibly dense. In fact, it has the mass of the Sun crammed into an object only a third the diameter of Earth. That's like trying to fit an elephant into a shoebox. And yet, despite its massive size, it's actually quite cool, with a core temperature of only about 12,000 degrees Fahrenheit. By comparison, the core temperature of our Sun is about 27 million degrees Fahrenheit. Since the discovery of Lucy in the Sky with Diamonds, several other crystallized stars have been found, some with diamond hearts the size of Earth. It just goes to show that the universe is full of surprises, and you never know what kind of treasures you might find out there in the vast expanse of space. And this isn't the only weird star we've discovered so far. There are many strange, unexplained things in outer space. For example, let's take Vega. Vega, also known as Alpha Lyrae, is a bright star located in the constellation Lyra. It's one of the brightest stars in the night sky, and is easily visible to the naked eye from most parts of the world. Now, Vega may look like a beautiful, bright star to us Northern Hemisphere folks, but little do we know, it's hiding a secret. It's actually quite squashed. You see, Vega's high spin rate causes it to bulge at the equator, kind of like a cosmic belly. It rotates once every 12.5 hours, which is pretty fast for a star, and it throws material out around its waistline. It's almost like the star is hula hooping. This material is further from the center of the star, so it experiences less gravity, causing it to cool and darken, leading to a gravity darkening effect. So Vega is basically a cosmic fitness guru's worst nightmare. Although for us stargazers, it still looks round because we're looking at it from Earth's pole end. However, if we saw it from a different angle, we'd get a very different view. One that might make us wonder if Vega has been sneaking some cosmic donuts behind our backs. But while we might joke about its equatorial waistline, there's no denying that Vega is still one of the brightest and most fascinating stars in our galaxy. But if you want something actually bright, then how about a supernova? Supernovas are giant space booms that occur when stars reach the end of their life cycle. It's like the grand finale of a fireworks show, but on a cosmic scale. They release more energy in a few seconds than our sun will produce in its entire lifetime. And this is exactly what happened to the next star of our show. This celestial object with a weird name, IPFT 14HLS. But there's a catch. It isn't your average supernova. Even though this star made a blast in 2014 and started to fade away like usual, recently it made an unexpected comeback and brightened once more. Talk about a dramatic entrance. And if that wasn't enough, this thing continued to fade and brighten at least 5 times in total, which is a bit like a yo-yo. It's like the star just couldn't make up its mind about whether it wanted to stay bright or fade away into the abyss. Also, when scientists measured the supernova's spectrum, they found that it was evolving 10 times slower than other stars. Maybe it's a supernova that just wants to enjoy its golden years. All in all, this object is a real mystery. But this is not the only star suffering from the 2-in-1 syndrome. At first glance, MY Camelopardalis appears to be a fairly common star, but after a closer look, astronomers concluded it was actually 2 stars in one. These 2 stars are orbiting each other at over 600,000 miles per hour. It's a contact binary star system, which means that the stars are so close together that they share a common envelope. In other words, they're so close to each other that they're practically smooching. These celestial Romeo and Juliet are one of the most massive known binary stars out there. Each of them individually weighs in at a whopping 32 and 38 solar masses, respectively. Astronomers also think that they might be on the brink of a stellar merger, which means that one day they might just combine into one giant superstar. Wow, who knew space could be so romantic? Next, introducing another long name, HD 140283, also known as Methuselah's star. This little guy in the constellation Libra has been around for a while. And by a while, I mean a really long time. Actually, scientists used to think it was older than the universe itself. Just imagine if it turned out to be true. But eventually, they figured out that it's actually around 14.8 billion years old, a peer of our universe. That's still pretty impressive though. This star is so old, it remembers when the Milky Way was just a baby galaxy. But despite all that, this star still has some life left in it. It's just starting to expand into a red giant, which is kind of like when you hit your 30s. Talk about aging well. But if all these things are somewhat comprehensible, then how about a star that was literally named WTF star by scientists? No, I'm not kidding. At least it used to be. Now it's called Tabby's star. It also has a more scientific name, but that one is a bit of a mouthful. But what's really bizarre about this star is its irregular dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turned on and off a flashlight. And it's not just a little dip, we're talking up to a 22% drop in light. So it's not because it sometimes gets blocked by a planet or something. Scientists have come up with all sorts of explanations for this strange behavior, from comets to dust to even an extraterrestrial megastructure. That's right, but before your imagination runs too wild, it's important to note that the most likely explanation is just plain old dust. Perhaps the star is surrounded by some kind of dust cloud, and sometimes it prevents us from seeing it clearly. Although this explanation is still not 100% confirmed, there are still plenty of mysteries surrounding Tabby's star. One thing's for sure, it may be a bit of an oddball, but that's what makes it so fascinating. So, there you have it, folks. We're left in awe of the incredible diversity and strangeness of the cosmos. There's so much more to discover out there, So let's keep exploring and keep being amazed by the wonders of the universe. Two pictures are rapidly changing in front of your eyes: our huge planet and a black void. The picture of Earth is getting smaller by the second. You're flying away from the spaceship into an endless vacuum and don't know what to do next. The International Space Station flies 250 miles above Earth's surface. A spacewalk is routine for astronauts who work there. Astronauts have spent more than 11,000 hours in the black abyss to this day. Fortunately, during all this time, no one has ever flown away into outer space without coming back, as we've seen in the movies. But unfortunately, astronauts face other, no less terrible, dangers during spacewalks. One such accident happened in 1966. Eugene Cernan put on a jetpack and went into outer space to carry out some repair work. The jetpack, which helps an astronaut control flight in zero gravity, heated up a lot. Eugene put on special protective pants made of metal to protect himself from this heat. The pants protection didn't work when he went into outer space. Instead of directing the heat away from his body, the pants began to heat up. The suit was heavy and uncomfortable, like a knight's armor. It rubbed his skin and restricted movement. Working in zero gravity is physically very hard, but Eugene also had to deal with his whole suit heating up that day. Inside the spacesuit, he felt like he was in a hot bath. High temperatures and hard work caused overexertion, dehydration, and severe weight loss. His face was sweating, and drops of sweat blinded him. During this spacewalk, the astronaut lost about 13 pounds of weight. Other astronauts came to the rescue and took him back to his spacecraft. To reduce overheating, they sprayed him with cold water from a hose. In a sense, to go out into an infinitely huge open space, an astronaut must put on a suit resembling a body cage. Another dangerous incident happened in 1973. Two astronauts, Pete Conrad and Joe Kerwin, went into outer space to repair a solar wing on the Skylab space station. The wing didn't turn around, and the astronauts tried moving it manually. Using force, they turned the stuck wing, but it pushed them. The push was so strong that it threw both astronauts aside. They didn't have time to grab onto a nearby surface and began to fly away into outer space. Fortunately, they had safety cables that didn't let the astronauts go away for good. By grasping them, the astronauts returned to safety. In an ordinary modern spacesuit, there are more than 10 protective layers. Such a suit protects against extreme cold and hot temperatures. It's tear-resistant and doesn't leak moisture from the outside. This protection is necessary to prevent depressurization. If a small passage appears between your body and space, then all the oxygen will start coming out of the spacesuit. The more oxygen the suit loses, the more vacuum it gets. This leads to terrible consequences, such as suffocation and increased body volume. It looks as if you start to inflate from the inside. In 2007, Rick Mastracchio went into outer space to do some repair work. For some reason, there was a hole in his left glove next to his thumb. It was on the outer layer of the glove. But the worst thing was that the astronaut hadn't noticed it. He continued to work as if nothing had happened. But one damaged layer could destroy the second. The second one could tear the third one, and so on, until the vacuum reached the astronaut's skin. Rick was supposed to work 6 hours in outer space, but during the 4th hour, he noticed the damage in his spacesuit. The astronaut reported this to command and received an urgent order to return to the ship. He never found out how the hole had appeared. Inside the ISS, there are many chemicals necessary for working in space. For example, ammonia has the property of freezing almost any surface. This chemical frost is used to cool some components of the station during overheating. The leakage of this substance on the ISS is practically impossible. This is exactly what astronaut Robert Curbeam heard from experts during the training before his first flight to space. But this accident occurred to him on his first spacewalk in 2001. Robert was working outside the space station when an ammonia leak started. The liquid splattered all over his spacesuit. A thick layer of ice quickly covered the glass. Robert didn't see anything. He feared that he had broken something, but the accident was not his fault. The protective layers of the spacesuit didn't allow Robert to freeze, but the ammonia severely restricted his movements. The main problem was that he couldn't return to the ship. Ammonia could get into the station, and this could lead to an emergency. Robert had to stand in outer space for 1.5 hours and wait for the leak to end. After that, he successfully returned to the station. To realize how difficult work is in outer space, we need to understand what a spacesuit is. It weighs 280 pounds, which is as much as a scooter. You won't feel its weight in zero gravity, but it will still make you sweat. Astronaut Chris Hadfield had described it by saying that every movement inside your spacesuit meets resistance. The suit scratches your skin, squeezes your bones and joints, and forces you to spend twice as much energy on simple movements. In such conditions, you start sweating and your eyes get wet. This moisture flies inside the helmet and blinds you until it evaporates. But if there's too much moisture, it can threaten the life of an astronaut. Such a case happened in 2013 with astronaut Luca Parmitano. He went into space to measure something outside the station. At one point, he felt that the back of his head was wet. He informed the others about it and got an order to return to the station. When Luca was coming back, he had to turn upside down. As soon as he did this, water gushed into his helmet. It covered most of his face. Luca couldn't see or hear. He tried to report the trouble to base, but the water covered his mouth. Fortunately, his partners rescued him and helped him return to the station. When they opened the helmet, almost half a gallon of water poured out. Astronauts' cables are some of the most reliable defenses against floating away into space. But what if one broke from a strong push, or because the astronaut didn't fix it well? For additional protection, there's a backpack called SAFER, Simplified Aid for EVA Rescue. It's like a jetpack. It releases gas from small tubes and changes the direction of your flight. If you're spinning in space, SAFER stops and aligns your movements. You can take manual control and fly using a special joystick. SAFER was first used in 1994, but before engineers created it, there was the MMU, the Manned Maneuvering Unit. In 1984, astronaut Bruce McCandless used it for the first time. You may have seen this famous photo where he floats in outer space without a cable. The problem was that Bruce was the first tester of such a jetpack. He wasn't 100% sure if it would work. He went into outer space and unhooked the cable from himself. There was nothing else to keep him from flying into the infinite black abyss, and his team wouldn't be able to save him. Imagine how scary it must have been. Fortunately, the jetpack worked. However, after 3 missions, NASA decided to stop using the MMU as it was unsafe. After that, engineers invented SAFER. Jetpacks and cables are reliable safety systems, but the best protection for an astronaut in space is their skills. Each astronaut has 6 years of higher education and several more years of training. They spend many hours training in virtual reality with spacewalk simulations. They train their body, endurance, and mind, since the main thing in a dangerous situation in space is not to panic and stay calm.
Now, did you know that there's an astronomical object in which space and time actually swap places? How does that work? And what exactly does swapping space and time mean? Well, let's figure it out. Imagine that you're on a spacecraft. The vehicle can only move straight. Your path leads to some inevitable point, and you have no idea what lies ahead. You can only hope that it won't be too bad. Meanwhile, everything around you is complete madness. A chaotic collage of many historical events. What do you see? Ancient humans and dinosaurs? The birth of the universe? Future? Who knows? That's what the universe would look like if we swap time and space. And theoretically, this is what you would see if you fell into a black hole and somehow were able to survive. But how is something like this even possible? First of all, let's discuss time and space. Imagine drawing a light bulb on a sheet of paper. Then grab one more sheet and draw how it lit up. Right now, it's just a small circle of light. Another sheet, the circle of light is growing. It gets bigger and bigger in size until finally it turns into a giant circle. In real life, the bulb lights up in the blink of an eye. That's because the speed of light is the fastest in the universe. But here, on our drawings, we capture the propagation of light frame by frame. We see how over time the light has grown from a small dot to a large circle. But if you connect these circles, doesn't it remind you of some shape? For example, a cone? Yes, exactly. This is called a light cone, and time is the central axis of this cone. Why? Because light turns from a small dot into a large circle over time. To remember it, let's draw a time vector, an arrow inside the cone. It goes from the past to the future. Meanwhile, the circles are space. In space, we can move however we want, in any direction. We can move up or down, in zigzags, and so on. But no matter what zigzags we draw along the timeline, we're always moving forward. We can't turn back in time, and we can't stop it. This helps us define time and space. Time is the direction in which the light cone is oriented. This is the direction where all our paths lead, and where our future inevitably lies. And space is the whole variety of directions perpendicular to the timeline. This is a straightforward graph. If it could be applied to the entire universe, then time would flow the same everywhere. However, if you've watched at least some popular sci-fi movies, you know that this isn't the case. In reality, time can be crazy. For example, if you're chilling near a black hole, what will be 2 hours for you may turn out to be 20 years for your friend on Earth. But why? Well, take a deep breath. Now, gravity comes into play. Oh, I know about gravity. It's that thing that helps me to stand on the ground, you may think. But it's much, much more complicated than that. Gravity is one of the basic physical forces in our world, and it's incredibly powerful. In fact, she's such a girl boss that she can distort space and time. She can literally influence the speed of time like an almighty wizard. How? Well, let's take something slightly bigger than a light bulb. For example, a supernova. Somewhere in the universe, a star has just made a boom. How do we know about it? Well, nothing in the universe, no sound, no radio waves, nothing, travels faster than light. So we'll know about the birth of a supernova only when we see it. And this will happen only when its light cone grows enough and reaches our planet. So the light cone grows and grows. So far, everything is fine. And finally, it reaches our planet. But there's a catch. You see, our planet is very massive, and it has pretty strong gravity. What happens then? Gravity changes the direction of the light cone. It begins to attract the cone to the center of our planet, and with it, it also attracts our arrow of time. That means it slows the time down, and the closer the light cone is to us, the more the arrow bends and the slower time goes. What does it mean? Well, for example, the fact that the watch on your ankle will lag behind the watch on your wrist, that your head is aging faster than your legs, and that astronauts in Earth's orbit age a little slower than people on Earth. This is what scientists call general relativity. Right. But how does this relate to our topic? How can we understand what will happen if we swap space and time? Don't worry, we're almost there. Now, imagine a cosmic body with incredibly strong gravity. It bends time and space so much that it feels like they swap. This is a black hole. A black hole attracts absolutely everything to its center. No stars, planets, no light can escape from there. Let's say our light cone is approaching it. First, as usual, time begins to bend toward the center of the black hole, attracted by its gravity. But the gravity is very strong, so it bends more and more, and time goes slower and slower the closer you're to the center. In the end, the light cone crosses the boundary of the black hole, the so-called event horizon. At this point, it gets so distorted that now it's literally pointing downwards. We can say that time has changed its direction. Time is pointing downwards. What kind of nonsense is that, you may ask? It'll be easier to explain in a real example. Imagine you're a crazy astronaut who decided to jump into a black hole, and there's an observer in the spaceship who watches you doing this for some reason. At first, for you, nothing changes. You look at your watch, you see that 5 minutes have passed, and everything's okay. But for the observer, first of all, you'll fall for a very long time. The observer has been sitting there for 50 years, and you're still falling, all because your time has slowed down. Secondly, since space is also distorted near the black hole, the observer will see how you'll begin to stretch like spaghetti. This is a scientific term, by the way. It's called spaghettification. And then you finally cross the event horizon. The observer doesn't see you anymore. Light cannot escape from a black hole, so your image won't reach the observer even if you're still inside. And what about you? What if you somehow survived? Remember, the time arrow is pointing to the center of the black hole. What does it mean? It means that now, the center of the black hole is your future. It isn't a place, it's a fate that you can't change. And wherever you came from, as well as the rest of the universe, no longer exists for you. Because now, it's not a place, but an event from the past. And since you can't turn back time, you'll never be able to come back. But what is around you? Complete chaos. The rays of light now move in all directions, forward, backward, and so on. The rays depicting the events of the past, the future, the present, all this is moving around you. In reality, space and time didn't swap places, but it feels like they did. Because in space, you can now only move forward, as if along a straight line. And time, reflected in the light rays, surrounds you everywhere and moves in all possible directions. And here we go back to the beginning. This horrifying example helps us imagine what it would feel like if time and space got reversed. Of course, all this is just theories and guesses. The very idea that we're moving in some one direction, the one we haven't chosen, and there's complete time chaos around, sounds quite frightening. And yet, it would be a very interesting experience. Sounds dangerous. Why don't you go first?
When you look at photos taken from spaceships or the International Space Station that show sunlit objects like Earth or the Moon, something seems wrong. Space looks too empty. No magical scenery of a nighttime sky full of stars. It would be incredibly boring to go stargazing in space, since the sky is always dark. During the daytime, the sky on our home planet is blue because of the diffusion of light. It happens when sunlight goes through the atmosphere. But if you were on the moon or somewhere else in space, there would be no atmosphere to spread this light around. That's why the sky there would always appear black. But it doesn't mean less bright out there. If you were looking out the window of the space station, you'd see just as much direct sunlight as you would gazing out of your apartment window during a cloudless day, maybe even more. When taking a picture on a sunny day, you'll probably use a short exposure, together with the narrow aperture setting on your camera. This way, just a short burst of light will get in. That's similar to how our pupils contract in sunlight so that they don't have to deal with too much light. And since it's just as bright up there in space, the process is the same when you take pictures of sunlit objects there. Using short exposure, you can get good, bright pictures of Earth or the surface of the Moon. But it also means there will be no stars in the picture. Even up there, stars are relatively dim. They don't emit enough light to show up in photos taken with such settings. Our home planet has a blue sky that slowly transforms into a beautiful orange-red palette at dusk and dawn. But if you ever get a chance to watch a sunset on Mars, you should expect the opposite, an orange-brown daytime sky that gets a bluish tint at sunset. First of all, Mars is farther away from the sun than our planet. So, when you're looking at the sun from the Martian surface, of course, it looks fainter and smaller. And not just that, the sun observed from Mars is just a bluish-white dot surrounded by a blue halo. The thin atmosphere of the red planet contains large dust particles. They create an effect called scattering. It occurs when the diameter of particles in the atmosphere is almost the same as the wavelength of the scattered light. This effect filters out the red light from the sun's rays, so only the blue light would reach your eyes on Mars. How come Earth doesn't have rings? All gas giants in our solar system, Jupiter, Saturn, Uranus, and Neptune, have such rings, whereas the rocky planets Mercury, Venus, Earth, and Mars don't. There are two theories about how rings can appear around a planet. They might be just some material left from the times when the planet was forming, or they may be the remains of a moon that got destroyed by a collision with some space body, or torn apart by the strong gravitational pull of its parent planet. The gas giants formed in the outer regions of our solar system, while all the rocky planets are in the inner part. So maybe the inner planets were more protected from potential collisions that could have formed their rings. There are also more moons in the outer regions of our solar system, which could be another reason why the planets there have rings. Also, bigger planets have stronger gravity. It means that they can keep their rings stable after they form. Some experts believe Earth used to have a ring system a long time ago. A Mars-sized object might have collided with our home planet, which probably created a dense ring of debris around it. Some scientists think that this debris formed not a ring, but what we know today as the Moon. There's probably a giant planet lurking at the edge of the solar system, far beyond Neptune. Scientists call this mysterious hypothetical world Planet 9. If it does exist, it's probably similar to Uranus or Neptune and 10 times more massive than our home planet. It's likely to circle around the Sun, but in the outer reaches of the solar system, about 20 times farther than Neptune. Another interesting theory says that Planet 9 could actually be a black hole the size of a grapefruit that warps space in a similar way a large planet would. Even though we once thought it was a rare substance in space, water exists all over our solar system. For example, you can often find it in asteroids and comets. It's also in craters on the Moon and Mercury. We still don't know if there's enough water to support potential human colonies if we decide to move there, but some amount of water is definitely present there. Mars has water at its poles too. It's mostly hidden in the layers of ice and probably under the planet's dusty surface. Europa, Jupiter's moon, has some water too. This is the most likely candidate we know about to host life outside Earth. There's probably a whole ocean of liquid water under its frozen surface. It might actually contain twice as much water as all of Earth's oceans combined. Neptune is unexpectedly warm, even though it's 30 times as far from the Sun as our planet and receives less sunlight and heat. But it still radiates way more heat than it gets. It also has way more activity in its atmosphere than you'd suspect, especially if you compare it to its neighbor, Uranus. Both of these planets emit the same amount of heat, even though Uranus is much closer to the Sun. No one knows why. Neptune has extremely strong winds that can reach a speed of up to 1,500 miles per hour. Can they produce this heat? Or maybe it's because of the planet's core, or its gravitational force? There's a monster black hole hurtling through space at a speed of 5 million miles per hour. Scientists located it with the Hubble Space Telescope. They believe it weighs as much as 1 billion suns. It was supposed to stay put in the center of its home galaxy, but some gravitational forces are pushing it around. At one point, this black hole is going to break free from its galaxy and continue roaming the universe. Luckily, it's still 8 billion years away from us. Solar storms are so powerful that they could leave us in complete darkness. Back in July 2012, the strongest solar storm in over 150 years narrowly missed Earth. Coronal mass ejections, or CMEs, are large bubbles of ionized gas. They tore through our orbit back then. If they had caught our planet in the crosshairs, we would have literally been in the firing line. We'd have faced solar matter hurtling towards Earth, damaging computers and causing power outages that would have lasted for months. A surprise solar storm hit us on June 25, 2022. One photographer even managed to capture stunning bright auroras that flashed across the dawn sky in Calgary, Canada, and lasted for 5 minutes. They were caused by the storm. Vampire stars are a real thing. They're part of a binary star, and they can literally drain the life out of the other star in the system. They do it to keep burning for a longer time. It works like this. A smaller star with a lower mass steals its sibling's hydrogen fuel to increase its own mass. This vampire star then becomes hotter. Plus, its color changes to striking blue. This way, it looks much younger. How sneaky. The color of the universe is dubbed cosmic latte. The light coming from our galaxies and stars within them, as well as clouds of gas and dust in the observable universe, have a specific color. It's an ivory tint, pretty close to white. The universe is beige because there are a bit more areas that produce green, yellow, and red light than those that emit blue.
Dust storms on Mars can really go crazy. They hurtle through the red planet's southern hemisphere, especially during the summer. These storms can grow and encompass large areas of the planet, as happened in January 2022. Then, a dust storm covered almost twice the area of the United States. Could it be something like this that caused one of the robots we sent to Mars to go missing? The atmosphere and climate are harsh on Mars. It's mostly a desert with strong winds and average temperatures of minus 81 degrees Fahrenheit. It drops down to minus 220 at the poles during the winter. A lander needs to be specifically equipped and very sturdy to withstand such conditions. But researchers thought the Beagle 2 could handle the difficult trip to the red planet. June 3, 2003. A team of researchers got one of their pioneering robots they were about to send to space ready. It was a small and compact lander called the Beagle 2. Its mission was to touch down on Mars and search for what the world has been actively looking for decades now: life on the red planet. Now, the touchdown was due on December 25th, but the signal never came. The team tried to contact the spaceship, but at one point, they had to accept they wouldn't be able to reach it. Some thought the landing was too difficult and complex after all, so the lander crashed. But they couldn't find any technical errors. Others had a theory that the lander may have become entangled in its own parachute and fell down to the surface of Mars. Either way, the Beagle 2 was considered missing, until 2015, when NASA took pictures of what could be the remains of the lost lander. They weren't just smashed debris, the components actually looked to be intact. The lander's remains were lying with its solar panels partially deployed around 3 miles away from the site where it was supposed to land. Apparently, the Beagle 2 managed to land successfully, but its radio antenna got blocked. That's why researchers couldn't control it from Earth or communicate with it. But no one knows exactly why it happened. Have you heard of a face on Mars? In the 1970s, one of NASA's spaceships took the iconic images of the Martian surface that showed a face-like formation, as you can see in the upper part of the picture. If you have a rich imagination, you can easily see a nose, 2 eyes, a mouth, and an unusual hairdo. Some even thought it was a monument built on the red planet by another civilization. How about some other unusual things people have found on Mars, like Happy Face Crater? You can easily see why it has this nickname. Or rocks in different shapes, a pancake, Brachiosaurus, or a fish. Mars also has a waffle-shaped island on its surface. It's a 1.2-mile wide feature you can see in the area of lava flows. It might be the result of lava pushing this formation from below. It seems astronomers have also got some images of blue dunes. It's a sea of stunning dark dunes that strong winds sculpted into long lines. They surround the planet's northern polar cap and cover a region as large as Texas. The red planet is usually known for its brown sandy dunes, so these ones certainly came as a surprise. In reality, though, they're not really blue. If you could visit Mars right now just to take a look, you'd see that these dunes appear brown and orange like the rest. And the picture is a false color image. Scientists often use false colors to highlight differences in something. For example, here it's the difference in depth. Also, the biggest valley on Mars is so large it could eat our Grand Canyon for breakfast. It's a fascinating system of canyons 2,500 miles long called Valles Marineris, and it's over 10 times as long as the Grand Canyon. Now, if you could stretch this Martian canyon, it would go from coast to coast of the entire United States. Since Mars doesn't have any active plate tectonics, no one knows for sure how this canyon formed. One theory says a chain of volcanoes located on the other side of Mars, the one that includes Olympus Mons, bent the crust from the opposite side of the planet. This powerful force caused cracks in the Martian crust, as well as activated enormous amounts of water lying under the surface. This water then emerged and carved the rock away. The force activated glaciers too, and they possibly created new pathways in this gigantic canyon system. Volcanoes on the Martian surface could have erupted about 50,000 years ago, although the most powerful eruptions happened 2 to 3 billion years ago. But the planet doesn't have active volcanoes today. Most of the heat stored in its interior during the planet's formation has been lost. So now, Mars's outer crust is way too thick for the molten rock to reach the surface. But a long time ago, eruptions formed giant volcanoes, and these volcanoes most likely had an important role in melting ice deposits, which released floods of water onto the Martian surface. Now, Mars has a thin atmosphere with a volume of gas, mostly carbon dioxide, less than 1% of Earth's. But 4 billion years ago, it was way warmer and wetter than now. Its atmosphere must have been thicker back then, too. That's why it could create a powerful greenhouse effect and trap sunlight. Mars also has a powerful magnetic field. Similar to Earth's, it formed because of the currents of molten metals in the planet's core. But unlike our home planet, Mars lost its magnetic field after its core had cooled down. And without it, the planet didn't have any protection from the solar wind, which is a stream of charged particles flowing from the sun. The solar wind pulled away most of Mars's atmosphere in just a couple of 100 million years, give or take. This is what makes those powerful Martian dust storms even more intense. Mars has a fascinating history. Judging by the planet's glaciers, Mars has probably gone through multiple ice ages, just like Earth. A team of researchers got images of about 60,000 Martian rocks. Rocks were different in size and distributed randomly, which means they probably formed during different ice ages. Glaciers hide their own stories too. Who knows what kinds of gases, rocks, or even microbes could be trapped inside? Now, if you could get into a time machine and stop at 4 billion years ago, on Mars of course, the chances are you'd see spectacular scenes of flooding. Maybe there would even be some form of life on the planet's surface. A strong meteorite impact that formed the red planet's Gale crater could be something that triggered that mega flood. After that collision, the temperatures on the planet got insanely hot. This caused the melting of all that ice that was stored on the Martian surface at that time. The flooding was so massive, it changed the geological structure of the planet's surface. It carved out big ripples, as well as waves in the sedimentary rock. Now, speaking of water, vapor has been noticed escaping the atmosphere of Mars. Also, researchers have found some evidence of water flowing on the planet's surface. There are dark streaks in the soil. They seem to get bigger in the summer and shrink over the winter. There are numerous dried-out valleys and river channels on the planet. It's possible that liquid water once flowed there. Now, most of it could be locked up in ice caps or even hidden under the surface. More and more things hint that Mars used to be habitable. Mars is the only planet we know about where only robots live. 5 rovers make up the Martian population. Those are Perseverance, Opportunity, Spirit, Sojourner, and Curiosity. These robots are there to take pictures and samples of soil and air, and maybe even find life on the red planet. And someday, we may reunite with them on Mars. Who knows? Oh, and by the way, if you really could get into a time machine and stop at 4 billion years ago on Mars, then I'd like to buy you lunch and talk about it. My treat.
Our moon could be hiding way more pockets of water than scientists used to think. Its surface has something called cold traps. Those are areas that are in permanent shadow. If you could stand near one of the moon's poles, especially the South Pole, you'd see such shadows all over the place, 15,000 square miles of them. There are tiny cold traps that are only 0.4 inches wide, and there are hundreds and thousands of bigger ones. These regions are in eternal darkness and might have even gone without the slightest ray of sunlight for billions of years. And now, scientists think they're hiding much more than we thought, including small patches of ice, no bigger than a penny. But still, something astronauts could use to drink or for their rocket fuel. The majority of the water could be stored in glass or somewhere between grains on the surface of the moon. One theory says 15,500 square miles of the lunar surface could have the capacity to store water. But no one can prove it until someone goes there in person or sends rovers that would dig under the surface. The moon is not entirely white and devoid of color. Apollo astronauts that landed there in 1969 said the moon was a bit brownish. Later studies showed some dark lunar areas display hints of brown and blue. Highland regions are yellowish, with faint traces of pale and pink. Colors are not the same everywhere because of different amounts of various metals that are present on the moon, like titanium or iron in the surface minerals. Our eyes are not sensitive enough to pick out such differences from this distance, but the majority of the lunar surface consists of minerals that are naturally gray, and that's mostly the color we see from our planet. When you're in space, you can't walk on the ground. No gravity, so no need to wear shoes. That's why astronauts mostly wear socks, or eventually add another warmer pair if they're cold. But something strange might happen to your feet while you're up there. First, if you have calluses, they may fall off after some time. One astronaut described his experience and said the bottoms of his feet became very soft, while the skin on the top of his feet became very rough, like alligator skin. He engaged the top of his feet to get around when he was using foot rails on a space station where they stay. It's not easy up there. Astronauts on the International Space Station, ISS, have to use foot rails and loops to remain steady. When they have to do regular things, like just getting a haircut. When they want to do training, they can strap their feet into sneakers on the exercise equipment. It's essential for them to exercise way more than they'd have to on Earth, around 2 hours each day, because the human body isn't used to moving or performing any actions we normally do without gravity that kinda holds us together. Plus, if you stay in space for a longer time, you can lose much of your bone and muscle mass. For example, you can lose almost 20% of your muscle mass if you spend only 11 days in zero gravity conditions. But if you were up there, there's no point in using weights, right? Zero gravity affects them too. Instead, astronauts mostly use a device outfitted with 2 small canisters that create a vacuum and allow them to pull against a long bar. On the ISS, you can also use a bike and a treadmill. Did you know that NASA spent millions of dollars developing a pen that you could write with in zero gravity? A pencil is not the best solution for space travel. They have a habit of breaking and shattering, which can leave graphite dust behind. Also, they're wooden, which brings a high risk of fire in the pressurized, oxygen-rich capsule. That's why even such an everyday thing as a pencil can be life-threatening in space. So, they had to develop the space pen. It writes crisp and clean and can't rely on gravity to make the ink flow. Instead, it uses compressed nitrogen to force ink out of the nozzle. This way, you can write while you're floating upside down or even submerged underwater. Even when they're up in space, astronauts still face everyday things, like that unpleasant itching sensation on their faces. They can't just satisfy it while in their spacesuit. They need to improvise, so sometimes they scratch the spot with a microphone attached inside of their helmet. Sometimes they attach patches of Velcro inside their helmet for such things. One of the most complicated issues with space trips is how to protect astronauts from space radiation. Our body has not evolved to handle proton storms and cosmic rays coming from the sun. Of course, spacesuits and the rest of the equipment are essential. Some research also showed an antioxidant-rich diet that usually includes a bunch of vegetables like spinach, tomatoes, and beetroot is promising when it comes to reducing the bad effects of radiation. Astronauts didn't always wear white spacesuits. During NASA's first manned spaceflight project, called Project Mercury, they had silver suits. But none of the astronauts went out and explored the vacuum of space back then. Silver is not a good color for that, because spacesuits have to be highly reflective. White is the best for that. That color is the most effective for reflecting radiation while in outer space. We're on Earth, which means the atmosphere is like a shield that protects us from 77% of radiation coming from the sun. But astronauts don't have such protection up there, and this means they're very vulnerable to severe sunburn and extremely high temperatures. A white spacesuit helps, the same way as white paint on your walls helps you keep an entire room cooler. A lighter color will absorb 35% less heat. White is not the only color in their closet. When heading into space or coming to Earth, they sometimes wear a bright orange suit. It's a color that attracts attention, so if anything goes wrong during landing and astronauts have to quickly leave their ship, the rescue crew will spot them more easily. But times are changing, so today we have more sophisticated tools to locate astronauts that need help, such as GPS trackers and transponders, so suits don't have to be orange anymore. Floating through space. Everything's peaceful, and you're enjoying the magnificent view of the dark and quiet infinity filled with billions of stars, planets, comets, suns, moons, and so many other things we'll probably never even discover. 95% of our universe still remains a mystery to us. But at least the view is awesome. But it's only good if you're tethered. What if something goes wrong on your spacewalk and you detach? The whole scene goes from a beautiful dream to a nightmare in a second. But don't worry. NASA has designed a special jetpack called SAFER, Simplified Aid for EVA Rescue. It fires compressed nitrogen from 24 thrusters, which is how it can steer the astronaut back to safety. In theory, you could vent some gas from your suit too, or maybe throw a tool in the opposite direction, which is how you'll push yourself forward. But it's tricky because you'd need to throw it precisely in line with your center of mass. Otherwise, you'll just start uncontrollably spinning, and before you know it, you'll become so disoriented you'll have no idea where to go, even if you could. But SAFER will automatically detect rotation and use its jets to help you stay oriented towards the safe spot. It took scientists 10 days to teach a goldfish to drive a car. They taught it to move its own tank towards a certain target, and in return, the fish gets a treat. This research could help us navigate through space one day. There has to be some mapping happening in our minds. That's how we potentially link our body parts and movements to changes we go through when we're in space. That's how we'll know how far we can extend our arm to reach for a cup of coffee without going too far and knocking the coffee over. The movement control is not the same as under the force of gravity, and we need to be sure if such maps in our brain differ between sea and land, or if it's something universal. So when I say scientists taught a fish to drive, that basically means if the fish saw a target, it should touch the wall of the tank facing the desired direction. That way, scientists could guide the wheels and move them where the fish wanted to go. Many people would like to fly into space. Zero gravity, a stunning view of Earth from one side, and the boundlessly frightening black area from the other. Yeah, it's all cool. But don't forget that this journey can turn into a nightmare. Lack of oxygen, floating in outer space and staying in a spaceship for a long time without understanding when you can return home. This last thing happened to a Russian cosmonaut. His stay in space is one of the longest in the world. 33-year-old flight engineer Sergei Krikalev spent 311 days in zero gravity on the Mir space station. But that's not the most interesting part of this story. Sergei's long journey began on May 18, 1991. That day, he boarded a transport ship and went into space to the Mir space station. On May 20th, the docking with the station was completed. There, together with another engineer, Sergei performed his space duties. They went on spacewalks several times, did repairs, took care of the station, and conducted scientific experiments. When you have company and a lot of work, living in space is not so hard. But things got worse on the day when Sergei was supposed to return home. According to the plan, the mission should have lasted for 5 months. A new astronaut was supposed to replace the old ones. The transport ship had finally docked with the station. But on October 10th, only one astronaut returned to Earth. Sergei was left alone at the Mir station. He continued to work as the sole flight engineer of the crew. The station couldn't remain empty. They had to send someone to replace Sergei. He wasn't ready for such a long stay in space. He hadn't trained for it, but there was no choice. He couldn't just leave the station. 1 month passed. They informed Sergei that he would return home soon, but something happened that no one expected. They contacted Sergei and said he couldn't return, since the country that promised to bring him home no longer existed. During this time, a big crisis began in Russia. The cosmonaut's return was impossible, since no one had the money for it. Just imagine Sergei's condition. You are hundreds of miles from home in black outer space, completely alone, and have no idea how many days you have left to be there. The days passed slowly, weeks, then a month passed. It would have been much easier if being in space was not harmful to your health. But in conditions of zero gravity, the human body takes serious damage. First, it's a weakening of the muscles. The body doesn't receive the necessary load it needs, and the muscles are constantly in a relaxed state, leading to dystrophy. Yes, astronauts do a set of exercises every day, but this is not enough to keep the body in shape. In addition to muscles, bones begin to weaken and a person becomes weak. Even after 6 months of such a life, any astronaut needs a long time to get back into their previous shape after returning home. Also, there's a lot of radiation in space, which is dangerous for people. It comes from several sources at once. The main radiation comes from the sun. On Earth, we're protected from it, thanks to the planet's magnetic field. Almost all radiation accumulates in the upper atmosphere and doesn't reach us. This accumulation of radiation in the atmosphere is also bad for astronauts. But the worst radiation is the galactic one. It comes from distant stars and galaxies and has a powerful effect on all living things. Radiation provokes many unfavorable conditions and destroys the body at the cellular level. Now, all spaceships and the ISS are equipped with shields and coatings that reflect radiation. But still, it doesn't provide 100% protection. In space, the astronaut's immune system changes. There are no conditions under which immunity could improve. It seems that there's nothing wrong with the absence of many bacteria and microbes, but the body's defense is weakening. A person becomes more vulnerable to microbes that can be brought by another astronaut. You also have serious food restrictions. Food in tubes doesn't contain as many useful vitamins as it does in natural products. Without vitamins, the body weakens even more. And sometimes, astronauts have to go on spacewalks, which aren't easy. A spacesuit is a huge and uncomfortable outfit. It constrains your movements and puts pressure on your body. Work in space can last up to several hours. During this time, you sweat a lot. One of the suit's filters may be broken, and all the fluid released by your body can spread throughout the suit and reach your face. Your eyes may water. The drops could interfere with your vision. Thousands of dangers can await an astronaut during a mission in outer space. Imagine that you do some repairs and something goes wrong. The wrench jumps off the bolt and it flies out, for example. You try to catch it and unconsciously push off from the ship. You catch the bolt, but your body is already flying away. You have nothing to hold on to. But fortunately, you have a safety rope. Anyway, it can break off from your spacesuit because you attached it incorrectly. As soon as the rope breaks, your body changes the angle of flight. Now you're not just flying away, your body is spinning at this moment. The Earth and black space flash in your eyes. So you get it. There are definitely risks, but nothing like that happened with Sergei. All astronauts spend many hours training to be ready for any troubles. They gain good physical shape and lose it during the mission. Add to this the psychological factor. Your body weakens, you don't breathe fresh air, you can't see your friends, and you don't have the opportunity to return home. A small layer of wall separates you from the cold vacuum of space. All this causes stress, which also weakens your immunity and harms your nervous system. Fortunately, astronauts also get through serious psychological training. They can maintain self-control in the most stressful situations. But when you're alone in space for more than 6 months and don't know when you'll return, you can get seriously nervous. Fortunately, Sergei didn't panic. He performed his daily duties, trained, and of course, missed home. A month later, he received the same response. "We can't bring you back yet. The country is in a difficult situation." He felt worse every day. His strength was leaving him. He wasn't sure if he'd be able to survive. The most interesting thing is the station had a capsule developed to return to Earth. But Sergei didn't use it, because no one would have served the station. Russia sold the station seats to other countries. Also, they hoped to sell Mir. This meant that Sergei had to keep the station working. Sergei's mission lasted twice as long as planned. As a result, he spent 10 months, or 311 days, in space, and set a world record. During this time, he flew around the Earth about 5,000 times. Finally, he received the long-awaited message. He's coming home. Germany paid about $24 million for a ticket to the station. They were going to replace the astronaut. Krikalev got into the capsule and flew to Earth. Many people were waiting for his return down there. The cosmonaut landed, and everyone rushed to help him. He looked very thin, sweaty, and exhausted. 4 men helped him out of the capsule. They helped him stay on the ground, gave him a fur coat, and brought a bowl of broth. It seemed that such a flight would leave an imprint on his life forever. But the cosmonaut's mood was excellent. 2 years later, he went into space again and became the first Russian cosmonaut to fly on a NASA shuttle. And 2 years later, he was one of the first to live on the ISS. In 2005, he made his 6th and last flight. He went to the ISS, where he spent about 6 months, after which he returned home on the lander. After this flight, he set a world record for the total duration of stay in space at 803 days. Only 10 years later, someone managed to break that record, but that's a different story.
Traveling at about 17,000 miles per hour, 250 miles above the Earth, astronauts watch 16 sunrises and sunsets every day while floating around in a box with a handful of people they depend on for survival. Whether humans should set off to other worlds beyond Earth or not, one of the most compelling drawbacks is this: our bodies don't like it. Few people know this better than the NASA astronaut who spent nearly a year on the International Space Station from 2015 to 2016, Scott Kelly. Like other astronauts, Mr. Kelly served as a test subject in the study of space travel's effects on the human body. Unlike other astronauts, Mr. Kelly has an identical twin, Mark, who is an astronaut himself. This gave researchers an uncommon opportunity to monitor the 2 brothers as they lived in 2 very different environments, one on Earth and the other 250 miles above it. When the astronaut went into space and his slightly older twin brother Mark stayed on Earth, the age gap between them increased thanks to his time in orbit. And it's all down to Einstein's theory of relativity. What it suggests is that time moves more slowly for objects in motion than it does for a stationary observer. It also moves more slowly the closer you are to a gravitational mass like Earth. In other words, we're not all experiencing time at the same rate. The faster you move and accelerate, the more time slows down. And because Mr. Kelly has been zooming up to and down from space and orbiting the planet at around 17,500 miles per hour, his brother Mark has lived through 0.005 extra seconds. The brothers were born 6 seconds apart back in 1964, and now that gap is 6.005 seconds. This warping of time is known as time dilation, and the Kelly brothers qualify for both aspects of it: how fast they've been moving in relation to one another and how close they are to a big object, which is Earth. So, depending on our position and speed, time can appear to move faster or slower to us relative to others in a different part of space-time. And for astronauts on the International Space Station, that means they get to age just a tiny bit slower than people on Earth. That doesn't mean you could spend your life in a basement just to outlive the rest of us here on the surface. The effect isn't noticeable on such a small scale. If you became a basement hermit, then across your entire lifetime, you'd only age a fraction of a second slower than everyone else above ground. But your brain might freeze when you think about this. A watch strapped to your ankle will eventually fall behind one strapped to your wrist. Your head technically ages more quickly than your feet. Time passes faster for people living on a mountain than those living at sea level. The classic example for this is the twin scenario. One twin blasts off in a spaceship, traveling close to the speed of light, and the other stays behind on Earth. When the space-traveling twin returns to Earth, she's only aged a couple of years. But she's shocked to find that her Earthbound sister has aged over a decade. Of course, no one has performed that experiment in real life, but there's evidence that it's real. When scientists launched an atomic clock into orbit and back, while keeping an identical clock here on Earth, it returned running ever so slightly behind the Earth-bound clock. Then time gets even more complicated, because time dilation can happen anytime. A good way to think about it is to consider the astronauts living on the International Space Station. They're floating about 260 miles above where Earth's gravitational pull is weaker than it is at the surface. That means time should speed up for them relative to the people on the ground. But the space station is also whizzing around Earth at about nearly 5 miles per second. That means time should also slow down for the astronauts relative to people on the surface. But the reality is that Mark, the brother who's aged a few milliseconds longer, could end up better off in the long run if Mr. Kelly's extended time in space causes his body to deteriorate faster. 10 science teams in NASA's twin study examined the brothers' astronauts before, during, and after the astronauts' 340 days in space. The teams studied each twin's bodily functions, they ran memory tests, and they examined the men's genes, looking what differences might be due to space travel. They confirmed that lengthy space travel stresses the human body in many ways. Space living can change genes and send the immune system into overdrive. It can dull mind and memory. Most changes that the astronaut experienced in space reversed once he returned to Earth, but not everything. The researchers tested him again after 6 months back on land. Roughly 91% of the genes that had changed activity in space were now back to normal. The rest stayed in space mode. His immune system, for instance, remained on high alert. DNA repair genes were still overly active, and some of his chromosomes were still topsy-turvy. What's more, the astronaut's mental abilities had declined from pre-flight levels. He was slower and less accurate on short-term memory and logic tests. It's unclear whether these results are definitely from spaceflight. That's partly because the observations are from only one person. But one thing is sure, time is relative. Think of it this way. If a clock is stationary and you are traveling at a very high speed, you happen to pass by this clock and have a glimpse at it, you'll see that it's running slowly, or maybe it's completely static. This is because the speed at which the mechanical functions of the clock are working slower than you. What you see is the time in the past, while you have already skipped that second and are in the future. During this experiment of high-speed traveling, you haven't aged at all, because all the processes in your body are working at the same speed as you. After a certain age, your body starts to deteriorate, which eventually leads to a state when it stops functioning. This aging phenomenon, especially in humans, is caused by a protein structure in the cells called telomeres. These structures protect our cells from deteriorating, but with each cell replication, these telomeres start to lose strength, which is called telomere length. If the telomere length shortens to a certain extent, the cell becomes vulnerable to diseases. We can say that telomeres are the natural countdown timers in our bodies, which determine when we will expire. The telomere length can be affected by external factors like stress, which accelerates our timer. The twin study experiment by NASA included documenting the changes in telomere length of both brothers. The telomere length of the space brother increased while he was aboard the International Space Station. Before the mission, both brothers had nearly the same telomere lengths, meaning if we ignore issues like mental stress, both brothers should live roughly an equal age. But while the space brother was orbiting the Earth, he had almost 14.5% longer telomere length. The space brother was a few years younger than his ground brother biologically. Because the telomere length of the space brother resumed to normal when he came back to Earth, it took almost 190 days after return for the telomere length to restore to expected. The blood samples from the International Space Station were sent back to Earth for processing. This means the blood wasn't traveling at the speed of the ISS anymore. Also, the space-time paradox states that the space brother should be younger upon return. But the telomere length restored to its original state before the mission. The space brother was again the same age as his ground brother. A lack of gravity is the main cause for these intense changes in aging. Gravity plays an immense role in the majority of our bodily systems. Take the muscles, for example. Older people's muscles tend to shrink and decline as they age and become less mobile. Astronauts' muscles react in a similar way because they are barely used. That's why astronauts staying in space for extended periods of time use special exercise machines to help reduce this effect. A similar process takes place in the bones. After a certain age, people on Earth start to lose mass in their bones, typically at a rate of about 1 to 2% a year. But in space, those people lose bone mass at a greatly accelerated rate, as much as 1 to 2% a month. Because the astronauts' bodies don't need to support their weight, the bones begin to decrease production of new bone material and increase the amount of old bone absorption. Luckily, their skeletal systems usually return to normal once they've spent some time back on our blue planet. If the space brother was shielded from all harms of space, like radiations, while orbiting the ISS, then he would have lived longer than his ground brother. Even though they're saving 0.005 seconds, astronauts still experience some of the symptoms of a drawn-out aging process. So the next time you find yourself wishing the weekend would last longer, stay low to the ground and move really fast. It won't feel like your weekend got any longer, but technically, you may gain a teeny tiny fraction of a second. You won't need to go to space for this little experiment.
It's probably one of the worst nightmares for an astronaut, to float away to outer space without any hope to return. Just imagine slowly moving away from the International Space Station into an endless black void because of some accident, somewhere where there's absolutely nothing but a cold vacuum. Fortunately, you still have an opportunity to survive. Let's have a detailed look at the moment when this can happen. So, you're on the International Space Station. It's now at an altitude of about 250 miles in the upper layers of the atmosphere. It's important to mention that it's not just hanging out there in space. Earth's gravity is constantly pulling on the station. Not to fall, the station needs to fly around our planet at a speed of about 17,000 miles per hour. That speed is fast enough to help the station fight the planet's pull. But on the ISS, when you go into outer space, you don't feel this speed. It seems to you that you're floating in one place, watching Earth spin. But there's still a lot of space debris that moves in the opposite direction. From the point of view of a person on the ISS, the speed of these objects is incredibly fast. You put on a spacesuit. It has oxygen supplies and is equipped with a water compartment so you can drink during the mission. So, you're about to walk into space. First, you need to go through a special door called an airlock. Once you're inside, you see that there are 2 doors here. You enter and close the first door to block access to the space station's oxygen. Then you open the door leading to space. What you're about to do is called a spacewalk. There are several reasons why you might be in outer space right now. You may be conducting scientific experiments to find out how different things behave in space. Also, you can be testing new equipment, sensors, and other high-tech gizmos. Another reason might be the repair of failed parts or routine maintenance of the International Space Station. Before taking a step into the void, you attach your spacesuit to a rope connected to the body of the ship. You can also fasten small cables to your tools, such as a screwdriver or a wrench, so that you don't lose them. You push off the ship and experience a feeling similar to swimming underwater. By the way, before going out into a zero-gravity area, astronauts train inside a huge swimming pool. You hold on to the parts of the ship and head to the place that needs to be repaired. Let's say you need to tighten a small screw. One astronaut once said that any work in outer space is difficult. You're wearing a huge suit that slows down your movements and makes you clumsy. It also makes your skin itchy. The work can last up to several hours. During this time, you sweat a lot. One of the spacesuit filters may be broken. In this case, all the fluid released by your body can spread all over the suit and reach your face. Your eyes may start watering. Tears will make your vision blurry. As you see, dozens of dangers are lurking out there in open space, and there are no clear instructions on how to deal with most of them. Anyway, you're tightening the screw, but something goes wrong. The wrench jumps out of your hand, and the screw flies out of the hull of the ship. You try to catch it, and accidentally push off the station. You manage to grab the screw, but your body is already flying away. You have nothing to hold on to, but you have the rope. And oh no, it's not tied to your spacesuit anymore. You've attached it incorrectly. Now you're not just flying away from the station, your body is also spinning. The views of blue Earth and black space switch in front of your eyes. You can't stop. Fortunately, the cable is not the only safety measure. Your spacesuit is equipped with a safer, Simplified aid for EVA rescue. This is a backpack with fuel that works like a jetpack. You activate the backpack, and it levels your flight. You stop spinning and calm down a bit. Now, you know exactly where the ISS is located. Next, you have to choose the direction manually and fly up to the station very carefully. The Safer releases gas from small tubes, and this makes you fly forward. Using the Safer control panel that looks similar to a joystick, you can change the direction in which the gas is released. This way, you'll steer your spacesuit. Make sure the station is in your line of sight. Press the joystick to activate the tubes, but take your time. You have to stabilize your forward movement. Pressing the wrong button can cause you to spin again, and this will reduce your chances of returning. Each astronaut spends many hours in a virtual reality simulator that makes them feel like being in outer space. So know how to control the Safer. You're approaching the station at a slow pace. Don't let the backpack speed you up. If you start to accelerate, you need to point the tubes in the opposite direction to slow yourself down. If you fly too fast, you can crash into the station and damage the spacesuit. You've finally arrived at the ISS. You need to cling to something and move toward the airlock. You feel as if you're climbing a mountain underwater. You get to the airlock. Phew! Well, let's go back in time to the moment when you were flying away from the ISS. So, you tried to use the backpack to level your movement. You're nervous and can't calm down. You randomly press the joystick and chaotically direct the tubes in different directions. A few minutes pass. You haven't come closer to the station, and the fuel in the Safer has run out. Now, you're even more nervous. Let's go back in time again. You float away from the ISS. Then use the Safer and slow down the rotation speed of your body. Now you're facing the ISS. You approach the station with slow but steady thrusts. Everything is going well, but at one moment, you notice some movement. This is a small piece of metal from an old satellite. It crashes into the Safer and slices through the backpack. Fuel starts leaking out into space. You start spinning again because of the impact. You don't understand which way you are moving. All you need now is to take a deep breath and use the remaining fuel to stop. Done. You're floating without rotating. There are no instructions and protocols that will help you get out of this situation. You're moving in outer space and can control this process. To return to the ISS, you need to push off something. Fortunately, you have time to think about what to do next. Your spacesuit has oxygen reserves that are enough for several hours. Also, you have water. You can drink it through a small rubber straw attached to the inside of your helmet neck ring. You're the first human in history who got into such a situation. But this doesn't mean there's no chance of survival. If you could throw something to the side, it'd set you in motion. For example, if you had a heavy wrench, you could throw it in the opposite direction from the ISS. This way, you'd launch yourself toward the station. But unfortunately, you have nothing to throw. You have your broken Safer, but you can't remove it without another person's assistance. You enjoy the beautiful view of Earth and try to breathe as slowly as possible to save oxygen. It seems there's no chance left for you. But at this moment, other astronauts call you using the radio. They see your location and are going to save you. Your colleague is heading in your direction. She's attached securely to two long cables. She's going to give you one of them when she reaches you. Using the Safer, the astronaut flies in your direction. She's very close. Finally, she slows down and grabs your hand. She unhooks one of the cables from her spacesuit and attaches it to yours. Using the cable, you approach the station. At this moment, a rusty bolt flies by. The main danger is that space debris can break through your spacesuit and tear the rope. You accelerate and reach the airlock, and then you open the door and dive inside. One of the most dangerous space missions has been completed. Theoretically, there's another way to save you. A spacecraft delivering food and air supplies to the ISS can pick you up and bring you back to the station. But this mission is even more difficult, as it requires a very precise route calculation. If something goes wrong, the spaceship can kick you. In this case, you will fly away at high speed. You can travel for several hours until you run out of oxygen, or a piece of space debris destroys your spacesuit. Fortunately, all astronauts are well-trained and experienced enough to avoid such accidents.
Another rocket blasts off from the launch pad and heads for the International Space Station. To deliver the payload there, you'd have to pay about $18,000 per 1 pound of its weight. Imagine spending that much money on just 3 bananas. So the weight of the rocket and spaceship itself is calculated literally down to every bolt and every ounce. But engineers normally use about 600 pounds of white paint to coat the rocket. That's $10,800,000. Let's see. You could buy a 3-masted schooner, a gold-plated Bugatti Veyron, or a penthouse in Manhattan, maybe 2 of them, for this money. Or perhaps even a private island. Well, a small one. But engineers have to paint rockets white so that they don't turn into flying ovens. Imagine sitting in a black car in a parking lot at noon in the summer. The air conditioning is off. You'll start feeling uncomfortable in a couple of minutes. But if your car is white, it will heat up more slowly. It's all about the reflectivity of the material. When the sun's rays touch a black surface, they get absorbed. As a result, everything under this surface heats up. But when the rays reach a white surface, they get reflected. This surface absorbs much less heat. That's why you feel much hotter wearing a black t-shirt in the summer than while putting on a white one. You also look hotter. But I digress. Spaceships fly in space, and the temperature there is about minus 455 degrees Fahrenheit. But space is also a vacuum. That means there's no air particles that can transfer heat up there. So nothing blocks the sun's rays and prevents them from heating up the surface of the rocket to insane temperatures. If the rocket was black, it would absorb all those rays, and astronauts would feel like a chicken in an oven. Besides heat, the sun emits radiation. Earth's magnetic field and atmosphere protect us from its destructive effect. But there's no such shield in space. So the white paint on the surface of spacecraft also protects astronauts from radiation. Spacesuits are white for the same reason. So is the International Space Station itself. On Earth, most airplanes are painted white. But even with white paint on the paneling, a spacecraft can heat up too much, and its other side, where the sun's rays don't reach, will cool down a lot. After all, space is very cold. So, engineers came up with a clever way to transfer the heat from the sunny side of the spaceship to its dark side. There are tubes under the paneling. They're filled with ammonia. The ammonia evaporates after absorbing the heat from the surface. Then it transports this heat to the colder side of the spaceship. There it gives off the heat and returns to its liquid form. After that, the ammonia moves back to the illuminated side of the spacecraft. The second reason why we paint spacecraft white is that space is black, and if you paint your spaceship black or any other color, you won't be able to see it. This will make it difficult to dock spaceships with each other or with the ISS. But a white spaceship is perfectly visible against the black background of space. The third reason is that you can see even the slightest damage on the spaceship if it's painted white. Long before launch, the spaceship is assembled in a hangar from dozens of different parts. Then it's delivered to the launch pad. And if something went wrong in that process, you will see any scratch or crack on the white surface. Or if any part is leaking, you'll quickly notice a stain on the white surface. But it's not just the surface of spaceships and the ISS that gets painted white. The interior is white too. If you look at photos of astronauts on the International Space Station, you'll see that most of the interior is either white or beige. Again, it's all about the reflectivity of this color. Electrical power is an important resource on the ISS. Every light bulb and LED must be used economically, and white surfaces effectively reflect the light from the bulbs all over the station. This way, it isn't dark there even without a lot of lighting devices. And this is the Saturn V, America's moon rocket from the 70s. It's the biggest, most powerful, and heaviest payload-carrying rocket ever made. And it's not completely white. Even more interestingly, its white parts are painted this way to provide protection from the scorching Florida sun on the launch pad. But you can also see black stripes all over the rocket's body. Thanks to them, cameras on the ground can determine its rotation speed. The point is that at launch, a rocket spins exactly like an arrow fired from a bow. This helps it to be more stable during the flight. When the rocket is launched and starts spinning, all video cameras are pointed at it. When experts watch the video of the launch, they analyze every frame. They pay attention to how the black stripes move. This way, they can calculate the rotation speed of the rocket. Now, let's take a look at the Space Shuttle. You can always recognize it by the huge orange tank attached to the spacecraft. It contained liquid oxygen and hydrogen to propel the space shuttle into orbit, and it was orange because it's covered with insulating foam. Oxygen and hydrogen can only be in a liquid state at extremely low temperatures and under high pressure. So engineers tried to protect the fuel from overheating with this insulation. But originally, this tank was white too. The reason was the same, to reflect the sun's rays. But later, engineers decided that the foam insulation would be enough and the paint layer was removed. So they managed to save about 600 pounds of weight and deliver more payload into space. And 600 pounds is almost 72 gallons of water or 900 large burgers. Wow, how did that get on board? Interestingly, the space shuttle itself wasn't completely white. It had a black bottom. That's to withstand the extreme heat of re-entering Earth's atmosphere. When the space shuttle completed its mission in space, it started to descend. At the height of, let's say, about 400,000 feet, it traveled at 25 times the speed of sound. When the space shuttle re-entered the atmosphere, it literally collided with air particles and began to break. At this point, its bottom heated up due to friction with the air. Try rubbing your palms together, they become warmer. The same happened to the bottom of the space shuttle, only it heats up to 2300 degrees Fahrenheit. By comparison, the temperature of a hot frying pan is about 6 times lower. Just touch it and see. Nah, don't. That's why engineers had to protect the bottom of the space shuttle from overheating with special black tiles. They're called HRSI, which stands for High Temperature Reusable Surface Insulation. Catchy. They're made of porous silicon, which means they're very light but can withstand extreme temperatures. But when it comes to new rockets, we won't have to worry about painting them white or protecting them with tiles. We'll build new rockets and spacecraft with stainless steel because it's easier, cheaper, and faster. Take the SpaceX Starship. This thing will be able to take people to the moon, and in the future, even to Mars. And it's made of stainless steel. 2 pounds of carbon fiber, which is used in conventional spacecraft, cost about $200. But the same amount of stainless steel costs about $3. And since the weight of the spacecraft and booster is about 300 tons, the difference is huge. Stainless steel does a good job of reflecting the sun's rays, too. Even though it's dark, it's shiny, so the ship won't overheat. In addition, stainless steel is great at withstanding low temperatures, so it won't deform in cold space. And to save Starship from overheating on re-entry, its paneling is designed like a sandwich. There's an outer layer of steel, then a layer of air, and an inner layer of steel. Kinda like an Oreo. The air acts as thermal insulation. So, Starship with people on board is attached to the booster on the launch pad. Ignition. The booster helps Starship escape Earth's gravity, then it undocks. At that point, Starship fires its engines and enters orbit. By this time, it has used up almost all its fuel. Meanwhile, the booster re-enters the atmosphere and makes a soft landing. It docks with a refueling ship. Ignition. The booster launches again, takes the spacecraft into orbit, and returns to Earth. The refueling ship docks with the Starship and replenishes its fuel supply. It also transfers cargo to Starship. Then it undocks and returns to Earth for its next mission. At the same time, Starship turns on its space travel engines and heads for its destination. The journey to Mars will take about 7 months. SpaceX also plans to use Starship for traveling on Earth. Launches can take place from water platforms near big cities. Then, the trip to the other side of our planet will take no more than 1 hour.
You're hovering about 18 miles above the surface of Earth and enjoying the best view of our planet. Whoa, that's a starfall! Make a wish. And that bright dot that's moving very fast is the International Space Station. And then, the waiter brings you a drink. Wait, why is there a waiter? Well, the thing is, you're on a tourist spaceship, and very soon everyone will be able to fly into space with giant balloons. This is Neptune. It's a round capsule with panoramic windows and a 360-degree view. It can take on board 9 people in comfortable seats, including 8 passengers and 1 pilot. It also has an under-deck toilet. As the manufacturers say, it's the toilet with the best view in the universe. There's also a luggage compartment for tools and scientific equipment in the roof of the capsule, a Wi-Fi connection that will even allow live streaming, and there's a bar with refreshments. Space Perspective, the creators of Neptune's plan to price passenger tickets starting at $150,000. And there's no rocket engines, are there? This thing will go up thanks to a giant balloon the size of a football field. Let's move to the launch pad. Passengers enter the capsule. Engineers fill the balloon with hydrogen. It's lighter than air, so the balloon begins to take off. When the thrust becomes sufficient, the capsule with the passengers takes off from the launch pad. The journey begins. The capsule and balloon go up at 12 miles per hour. That's twice as slow as a person can run, and 2,000 times slower than a conventional rocket takes off. So you won't experience hard overloads, vibration, and noise like you would on a conventional rocket. So you're already at 45,000 feet. It's almost halfway there. This is where commercial airplanes fly. This is the frontier where the weather ceases to exist. No clouds, no wind currents or turbulence, but no oxygen either. You'd need an oxygen tank to breathe here, but the Neptune capsule is airtight, so you keep climbing. You also notice that the balloon has grown up several times. This is because we filled the balloon with hydrogen at 0 altitude. The hydrogen was putting pressure on the balloon from the inside, but the air from the atmosphere was putting pressure on the balloon from the outside. But the higher up you go, the less air there is. Hydrogen continues to pressurize the balloon from the inside, but now nothing is stopping it from expanding. So we need a very dense material that can stretch for the balloon. Humanity launches such balloons with weather probes all the time. They take off and get bigger as they ascend. But at extreme altitudes, the balloon material can't withstand the pressure, and it pops. The weather probe falls to the ground. We don't want the capsule with people to fall, so Neptune won't take off that high. But in case of emergency, Neptune has a parachute for safe landing. It's already deployed, and it's attached to the rope that goes to the balloon. So in case of unforeseen events, the parachute will instantly open, and the capsule will begin its slow descent. The entire takeoff procedure lasts 2 hours, and you reach the 100,000 feet mark. In human history, only about 20 people went to the stratosphere by balloon. The capsule hangs in the air. Now you and all the passengers have 2 hours to admire the curvature of the Earth, take endless selfies, and relax. You can even see a blue stripe over the surface of the planet. That's our atmosphere. And if you look up, you can see the most beautiful starry sky of your life. Because there are no clouds or light pollution from the big cities at this altitude, and you can see the stars in all their glory. For the same reason, we send our telescopes to this altitude. 2 hours have passed. It's time for the descent. This procedure is slow and gentle too. The balloon is lowered. Atmospheric pressure begins to press on it again, and it shrinks in size. The capsule will land on the water. It has a splashdown cone at the bottom for this purpose. This thing will help dampen the impact on the water so that everything happens softly and smoothly. 2 more hours of descent have passed. The Neptune touches the water. Now a ship is approaching the capsule. It takes the passengers on board and takes them to the shore. It also takes the capsule itself on board for relaunch into the stratosphere. But the balloon itself can no longer be used for a new trip. As soon as the passengers touch the ground, their journey is over. The first person to ascend to the stratosphere in a balloon was this Swiss man, Auguste Piccard. He designed this round gondola. It was airtight and could take 2 people on board. The gondola was attached to a huge balloon as big as a basketball court. As with Neptune, the balloon was filled with hydrogen. In May 1931, Auguste Piccard and Paul Kipfer began their flight. As they gained altitude, they discovered several problems. The airtightness of the capsule was bad. Air would escape from the capsule, but they were able to fix the problem. They were climbing higher and it was getting colder outside, but the temperature inside the gondola reached 100 degrees Fahrenheit because the crew couldn't control the air release valve, so they felt like they were in a hot desert. Auguste's gondola reached an altitude of 51,775 feet, only 16,000 feet higher than commercial airplanes fly now. And 17.5 hours after launch, Auguste landed back on the ground. During this and other flights, the scientists collected a lot of data about the wind in these layers of the atmosphere and cosmic rays. He was also the first person to send a radio signal to Earth from such an altitude. Later, Auguste Piccard used the idea of a fully airtight gondola to dive to extreme depths. He created a bathyscaphe, capable of descending to the deepest point on our planet, the Mariana Trench. Even though the Neptune is much more advanced, it still can't fly into space. It's not even close to it. So this is where Auguste Piccard was able to fly to. Here is the maximum altitude of the Neptune, but space much higher. This is the Kármán line, about 62 miles above sea level. Humanity considers this to be the boundary of our planet, so the tourist in the Neptune capsule won't even be able to feel weightlessness. But if you want to become a space tourist and dance in zero gravity, there are a few more options for you. This is a crude, suborbital reusable spacecraft. The journey starts on a regular runway, just like a commercial airplane. Here you can see the unusual White Knight 2 aircraft. It's as long as a tennis court and consists of 2 fuselages. Because of this, it has a wingspan as wide as a soccer field, and our Spaceship 2 is attached right between these fuselages. So, White Knight 2 takes off like an ordinary airplane and reaches an altitude of about 12.5 miles. Then Spaceship 2 undocks and begins an independent upward flight. This small spacecraft is the size of a swimming pool. It's controlled by 2 pilots and carries 6 passengers. Ignition. The rocket engine is on, and the spacecraft begins to gain altitude. The pilots and passengers have reached about 282,000 feet, almost 3 times higher than the Neptune balloon. The passengers were able to experience weightlessness for a while. Then the Spaceship 2 began to land. The pilots didn't start engines anymore, they just glided in the air. Then the spacecraft released the landing gear and landed on the runway like a regular airplane. The creator of this company, which owns Spaceship 2, plans to carry out such tourist flights into space more often. The ticket for such a trip will start at $450,000. That's 3 times more than the flight on the Neptune balloon. If that's too much for you, we have another option for flying into space. This is the New Shepard spacecraft. This thing consists of a propulsion module and a crew capsule. It launches just like a conventional rocket, vertical takeoff, fast acceleration, and high overloads. The propulsion module helps the capsule reach a speed of about 2,230 miles per hour. At that speed, you could cross the United States from coast to coast in just 1 hour. The booster rocket climbed to an altitude of 65.7 miles. At this point, the crew capsule undocked and reached an altitude of 66.5 miles. The 4 passengers on board at this point felt weightless for several minutes. At this time, the launch vehicle descended to the ground and then made a successful landing. A few minutes later, the crew capsule began its descent. It launched 3 parachutes for braking. Just a few feet before touching the ground, the capsule makes a quick launch of the rocket engines to slow down completely and make the landing as soft as possible. You can become a space tourist and experience weightlessness on this rocket for only $250,000.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends.